so we'll try to keep on time. Thank you. Actually, do ask me questions during the presentation, so when the time is over, we'll stop. So practically, you heard this morning about the DataMed implementation, and you heard already DATS named a couple of times, probably more than a couple of times. So what I'm going to give you is it's a quick overview, and then actually closing. The final slide would be linking to the people who will present afterwards what the relation is with DataMed, so that at least there is a linkage, and indeed you will see the collaborations. So first of all, where to find information. Everything is available directly from the home page, okay? There is just a specific page on metadata standards, and because we have everything in the GitHub repository, we also push everything in the Nodo, and for people who want to read the PDF and do not want to log into GitHub to send the comments, we also provide a Google document that there is no need for a login and you provide the comments. So everything is available in as many formats possible, depending on your preference to provide a comment on. Okay, so what is that? So this is the first slide that is really explain why we decide to call this model DATS, because DataMed is supposed to do what PubMed has done for the literature. It's supposed to for data, what PubMed is done for literature. As you know, to be indexed in PubMed, you need to provide something called a DATS file, which is a journal article tag suite. It's just an XML file that describes certain metadata information. Now, on the same line, to be indexed in DataMed, there is metadata element to be provided. So we use, an acronym which is pretty similar, and that's why we decided to go for a data tag suite DATS. Okay, so this is also linked back to what Lucilla said a couple of times. This is not just an effort from my team or the core developer team. This is an effort from a lot of people which have contributed over time to the working group 3, which is the working group I've been chairing. The first phase was a very large open phase with a lot of teleconference and etc. But as the work started being, developed and we had versions of this DATS, we moved to more like, GitHub, Google Documents, and etc. Because running this code is very time consuming, and not everybody is always up to date because can't participate on the call. So as you can see, a lot of people have been part not only of this metadata working group 3, but also we have another working group that George has chaired, which has collected information about accessibility metadata for the datasets, whose results then has been included into the DATS model. And the core development team and any other pilots and any other people who have actually commented on the DATS, we have taken on board information and we have provided a list of versions for the DATS. So this has been, a quite a long process, and this is not completed, of course. We also took on board the comments from the first working group, the first repository workshop, which was held in June at BioCandy. And again, people reviewed the model, how to implement it, what was difficult, what was easy. We took it on board, and we always try to improve it as much as we can. So very briefly, what is that supposed to cover? It's supposed to cover key metadata experiments. The key information, and it's always been a use cases driven development process, because it's very easy to create a model and just put modelers in a room and you have a very complex useless model. But our idea was, this is the list of queries we need to meet. Let's see how we can try to build a model with as less as a metadata element and less complexity as possible. They try to fulfill as many of the use cases as possible, but not certainly all. So this is in a nutshell the development process, what we have done. We started collecting certain competency questions, and this is what we call a top-down approach. And then we also look at different existing metadata schema from different repositories, from the community standard. This is what we call a bottom-up approach. The combination of the two created the different version of the DATS. And this is just one slide, which I'm not going to go over, but because I've already posted my slide in SlideShare and linked them already to the BioCandy page for this meeting, it's for your information if you want to look in more detail. We collected the list of questions from DNH, from the community. The list of questions was clean, harmonized. We aligned what the metadata elements were. We tried to classify the metadata elements so that we could derive the key elements of this model. And when I say that we look at different metadata schema which are out there, there are many. And as part of the biosharing catalog of standard, we actually have many of them and we register them. And this is some of the metadata schema and standard that we look at and we use and we map them all. So all these files are all available in the GitHub repository. We map them all to see which metadata element they had in common, because obviously if something like, sample ID and a description, elements like these obviously are very common across all the schema, this means they are important and they have to be that. And as I say, the combination of the two, the top-down and the bottom-up, is creating the DATS. But we already know that we are not creating the perfect model because there is no perfect model. And there's always somebody who will say there's too much and somebody will say there is too little. And this is the real problem. There is no way to solve this. So the idea was to really aim to have the maximum coverage of the use cases with the minimum possible number of metadata elements. Okay, that was the goal, and that is still the goal. So let me walk you through the model. I'm trying to do this in as simple way as possible. So first of all, also to try to make the model simpler to the people which are new to it, we define what we call a core set of elements and extended set of elements. So the core are very generic, and they are not specific for the life of biomedical sciences. They are really very, very generic. The ones which are extended, they are a little bit more biomedical, but never grow deeper in a domain. They don't. And that's where I'll talk about the relation with the omics DI, which goes deeper in a domain. That's how we want to complement other indexes, which are more domain specific. So there is a core and there is an extended version. And let me also say that none of the entity it's mandatory. There's no mandatory thing here. If you have it in the database, then you provide it to DataMed. If you don't have it, there's nothing we can do. But this is not going to stop you to be indexed. That also needs to be made very clear. General design point. So because DataMed wants to index not just archived experimental data set, like the one you can find in GEO, for example, but also want to index more data set which are in reference knowledge base, like in Uniprot. This is something that we bear in mind when we build the model. And so the idea that the core of the model is a data set, and this refers to Ivy, what you were saying before, the software. I will highlight a couple of elements afterwards, but in reality the core is the center is a data set as an entity. We also have an entity which is called standards, an entity which is called software, but because our understanding is this will be indexed somewhere else, we link to them, and there are a few properties that enable the data set to be linked to the software, the data set to be linked to a standard, which are indexed somewhere else. And I'll also have a couple of screenshots. Can explain this more clearly for us? Okay, so this is one of the useless screenshots, but yet I want to show you in one slide the entire DATS. This is core and extended elements. As you can see, it's not enormous, right? It's not that big. But let me show you the core elements. They're just 18 elements. Okay? And again, there's nothing really big or too difficult. Of course, everything is difficult at the beginning if you have to map it with your own, try to understand the meaning of each label. Fair enough. And of course, in the specification, we have the definition for each element. We have the property, the definition of the property, the value, and so on and so forth. This slide here shows that also in the 18 core elements, those elements, each of them have several properties, but only very few properties are mandatory if you have that element. Okay? Again, it means that it's the amount of work to be done to provide a DATS compliant metadata. It's not enormous. So what I want to highlight here are a couple of those elements. Actually, after the next slide, what this slide really says that the core elements, as I said before, are very, very generic. They're not necessarily biomedical related. As you can see, are really very generic and really respond and enable to do very generic queries. And one important query, of course, is grants. It's something I want to highlight because we also have a link to grants, because we want to make sure that when you retrieve a data set, you know who has been funded by, what the grant number, and so on and so forth. Okay, so I want to highlight a couple of those elements which are part of the core. One element is the standards. As I say, this is not part of indexing standards, but what the idea is, if a data set is compliant with standard, let's say it's a data set from Express, we want to highlight the user that this data set from Miami Express complies to the Miami checklist. Or if a data set comes from the Omics DI and it comes from Pride, it's compliant to the MIAPE checklist, which is the minimum information about proteomics experiments. And highlighting that certain data set comply to the community standard, or for example, are annotated with an ontology, like Chris Newell was suggesting earlier. I think it's important for the user to know once they start retrieving the data set. So what we do, the idea is to then understand which is the standard and the ontology, if the database is able to tell us, associated to the data set, and then link to the description of that standard or that ontology, which is actually listed in biosharing, which is a registry of standards, which is also part of the Elixir ecosystem. And this is just a screenshot that, for example, we have in biosharing, we have all the links standards that we put together with Kathy from Stephen Schwerer's team, because the idea is that if we are to list all the data sets from the links data set in DataMed, it would be nice to show them to which standard from the link standard set they are complying to. Software, again, it's important to know the software which is related to a data set. So the idea here is to point to the external index that has the information about the software. And here it's a screenshot that Jeff provided me from the resource identification portal. It's a SciCrunch system, where actually all the the software in this case is listed. And so we can point to other tools. We can point to Aztec. We can point to anywhere to BioAztec. We can point to anywhere where the software is actually listed, so that more information about the software are provided. Another important element, which was prompted by Vivian's comment earlier, was about the distribution and access. So knowing about the data set distribution is pivotal. Let's say if there is an API, you want to access the data set and then download it and etc., you need to know where this data set is served from. It's an FTP, for example, in which format is provided. But what you also want to know is the access. Can I access it? Is there any authorization or required for that? And that's a very important element. The access metadata information and all the property come from the working group 7 that George co-chair, which now become part of the DATS. It's an important element to the data set distribution because we came across to a very recent set of W3C recommendations. They've been released on August the 30th. And this is a new working group in W3C about data on the web best practice. We look at those best practices, and actually we see that in the DATS model, we actually follow many of those practices. And one of the recommendations from this W3C group is to indeed have data set distribution, so that you know from where to download information and what's the property for these elements. Okay, let's go into the serialization discussion. Okay, the model is the model, but actually how is it implemented? And this also linked to Harold, your comment earlier, that we need to down because this is an ongoing discussion. So data set, we decided to use the JSON schema, and so there is a serialization in JSON format, and we then also used the schema.org vocabulary. So we have a JSON LD schema.org annotated serialization. Now, of course, this doesn't have to be the only serialization. We could have an XML if you want. I know you're doing the OWL. It's just, it can be done. And just understanding why, what's the difference, and the need, and etc. I also want to point to something which is on the GitHub for a more technical person. There is a context mapping file, which means, actually it's a mapping between the JSON and the schema.org element, but in the same way, if we were to choose another vocabulary, we could have a serialization using another vocabulary. But let me tell you the reason why we have used schema.org, or at least we're testing schema.org, also because this is being discussed under the DNH Commons concept, the importance of using schema.org or the value of it. So as I say, that schema.org, it's not a vocabulary, the schema, but vocabulary, which is used by big search engine consortium like Google and Yahoo and so on and so forth. The benefit for using it is that once we have all the metadata index in DataMed, which is also annotated with schema.org, we will be indeed more searchable through Google as well. So you enter something in Google and you will find an entry in DataMed. That's the whole purpose of actually doing it. It's an ongoing discussion because it's not a done deal. What does it mean? It means that schema.org does not have all the vocabulary that we need to annotate the elements in that. Okay, so what the team is doing, it's actually taking the missing elements, submitting to the tracker of schema.org, and having the schema.org group to decide if that can be added or not to the core schema.org elements. But we're also working at the same time with another initiative that Jeff earlier mentioned, which is called bioschemas, which is also part of the Elixir activity, where it's a group of people working in the life sciences and trying to send schema.org into a certain area for life sciences, because as I say, schema.org is not complete, doesn't have all that you need. Now, under bioschemas, for example, we are extending it to describing training material, but we're also extending to describing datasets in the life science. And at the same time, Harold also mentioned that there is a health life science extension to schema.org, although that's very much for clinical study. And that's, again, another people we're discussing with, and as representative, it's also part of the working group tree. So as you can see, it's a lot of things which are happening and have to continue to happen. For those who want to know about the detail, in the GitHub you will also find the mapping between the DATS element and the schema.org. And in red you can see the elements which are missing. In yellow you can see the elements which don't necessarily map precisely. And the ones which are not marked are a good overlap. So this shows that there is work that needs to be done with schema.org. As I say, it's not a done deal. Okay, so let me tell you, I'm almost done. I have the final slide where I'm related to the different people which are talking afterwards and exactly what the relation with the DATS is. So the first slide, it links to the CEDAR Center. So Mark Busen will present the CEDAR Center afterwards. I'm also a co-investigator in the CEDAR Center. So CEDAR is a center for annotation, for extended data annotation and retrieval. There are tools have been built to easy the annotation of data sets, so the authoring of the metadata that describe those data sets, using the standard, using the ontology, etc. So the idea here is, because DataMed is about search, it's not about data submission, data annotation, but CEDAR is about the latter. The idea here is, if somebody does not have the data set in a formal repository but wants to be indexed in DataMed, the idea it's not just the idea, actually it's happening. We have created, well, the core team, and Jack in particular, has created with the CEDAR team an entry form, a template for describing data sets following the DATS metadata, and this is happening in the CEDAR tool environment. Okay, the second one is actually the relation with the Omics DI that Henning and Jakob will present afterwards. The Omics DI, it's a Omics Discovery Index, part of the Heartbeat 2K, which I think has the best logo and name I have to say of the BD2K Center. And so Henning will actually show the Omics DI afterwards. But as Lucilla showed before, DataMed can also index data from aggregator, and Omics DI is already another index, an aggregator covering the Omics data space. So what this actually, a spreadsheet here is just to work between my team and Henning team, is to simply map the DATS model with the Omics DI model, which were developed somehow, in parallel, and simply show that we have a lot of overlap in the core elements, and the element you read, which you can't read, of course, are the ones which are in the standard, but probably Henning will tell us more about how he will develop and extend the Omics model more for the molecular level, which DATS would not go. Okay. So the one before that is actually the relation between the DATS and the data citation implementation pilot, which Tim Clark already presented earlier. So as you already heard from Tim, It's about data citation implementation, and one of the work, which is an been supplement to 411 group. One of the working group within the pilot is actually working on the landing page, metadata for landing page to enable data citation. So Tim kindly provided me with the table, which actually, as you can see on the left-hand side, has the metadata, and it's very important for data citation. That should be on this landing page of the repository. And on the right column, you can see the DATS element. So I think there is a very clear, of course, overlap. DATS has more elements because to describe and reuse the data, you need more elements than to cite the data. Okay, but that's exactly why they are a subset. But of course, there is a clear overlap. My last slide. Okay, you cut my last slide, Elizabeth. Anyway, my last slide, which I'm not here, is that internet here. I wanted to show because it's quite important. It's with DatAsets. No. So yeah. Thank God I posted my slide. But I think probably by doing it you cut it. That's okay. It's done. There it is. I put it on slide share. So I just want to click here and go to the DATS slide. Oh, sorry. Sorry. That's it. You know, I'm not techie. That's done. I've reached it. That's the last slide. I wanted you to show it. Thank you. Technology helps me now. So, and that's an important activity also because Martin Fenner, which is the technical coordinator of DatAsets, it's also part of the data citation pilot team. So, you know, as you can see, it's a lot of connection. So DatAsets is essential because it's the non-for-profit that gives the DOI to data. Now, when somebody needs a DOI, at the same time has to provide back to DatAsets a set of metadata elements. Okay, so that, you know, that describe the data set. What we have done with Martin, we've actually mapped the metadata with that, and we saw that a lot of things we need were common, and actually somebody from DatAsets was part of the working group that has developed that. But practically, what's happening now DatAsets will also want to take the subset of dataset descriptor, which are for the biomedical area, and export from the DatAsets metadata into that so that they can be indexed in DataMed. And this is already happening because Martin has created an API for DatAsets where you can actually see a first draft of a DATS. It's not a final one. We're refining it. But he wants to go one step further, and we're very happy to refine the collaboration with DatAsets because the DatAsets schema, so the specification that people are given when they mean the DOI and provide the metadata to DatAsets, has a specific element called a related identifier, and this has a metadata relation type. So what is going to happen then? People that are minting DOI, if they are from a database which is in the life sciences, they will be suggested to provide additional information to the DatAsets metadata, and that additional information is the DATS metadata element. So you will hear more about this collaboration as it gets finalized and the example is put on the website. Thank you. Probably longer than expected.